Hello again, guys. It's been literally 2 seconds for me. For you though, take a break before each video. That's my suggestion to you, just to keep your mind fresh and take other pauses if you need to as you go. Now we're gonna jump into questions. Every time we do questions, what I'd like you to do is just pause the video and try it out by yourself first. See if you can come up with the same answer on your own before you watch the solution. Okay, so take a moment right now, pause, do the question, and then let's talk about the answers. All right, so these questions are about determining whether a data set is a population or a sample. So they're going to give you a data set, and your job is to determine, is it a population or sample? Simple, simple. And you have 50-50 chance, right? If you just guess randomly, 50-50 chance. Of course, we don't want to just guess randomly. We want to figure out what and why. What and why. That's exactly what we're after. Okay, so letter A, the salaries of KCC professors. Oh, whoa, interesting question. Is it a population or sample? You know, the funny thing, guys, is that it can actually go either way. It really depends on context. So what I'm going to do is give you the initial answer that I think is most natural. Here's the most natural answer, or what I would think is the quote-unquote correct answer. But even though I say correct answer, with the proper justification, you can actually flip it either way. So what's the technically or most intuitively correct answer? I'd say that this is a population. And why is it a population? If it's a population, then what you want to do is figure out what do a sample look like. So it's a population because we're talking about all, and that's the key word, right? All salaries of KCC professors. Now, what would a sample look like? Maybe a sample might be salaries of all math professors. That's not a very good sample because math professors maybe for some reason they make more or less than the rest. The salaries, excuse me. But it is a sample nonetheless. A better sample would be, or okay, another sample could be a random selection of the salaries of 100 KCC professors. Okay, so that's the justification for why I would say that the most natural answer for letter A is population. Now, here's a reason why you might disagree with me, and you could still actually be correct. So, alternative answer. And yeah, like the thing is, this is kind of what I personally don't really like about statistics, is that there's a lot of ambiguity in certain aspects of it like this, right? And typically thinking math is like there's always one answer, but there's not necessarily one single answer in these cases as long as you have the right context. So what would an alternative answer be? You could say it's the sample. Why? Well, because what could a population be? Maybe the population you're looking at is the salaries of professors everywhere. So all professors in the entire world, right? So then salaries of KCC professors would only be a sample. But that's to me an unnatural answer. That's why I say it's the alternative, because what population is KCC professors going to represent accurately? Basically none, right? Because that's a very specific niche sample. So it's not a good representation of professors everywhere, because like my thought is KCC professors probably make a lot less than the average professor. Just my guess. not to say anything about what my salary is. Okay, letter B. So I'm gonna erase that one. Let's read the natural answer up as the quote unquote correct answer. Letter B, salaries of 10 professors, and again the correct answer is a sample this time, and that's pretty obvious based on the previous question, right? It's only some of KCC professors. So if your answer is sample, then what would the population be? The population would be all KCC professors. Or you could say even broader than that. You could say all professors everywhere. But 10 professors at KCC would be a good representation of population of all KCC professors because they're all at KCC, right? Oh, excuse me. Okay. So what would I'm not going to write this one down because this one doesn't make as much sense to me. Although it's technically still possible to say that it's a population if you only want to study those particular 10. That's all you care about knowing anything about. You could say that was your population, and then a sample would be something like only 3 of the 10 or something like that. Okay, but that doesn't make as much sense to me. Okay, letter C, a survey of everyone in the United States. Again, coming back to technicality here, if we're talking about the data should actually be the survey results. So of some whatever survey it is, that's technicality. But let's just leave it as it was. The survey of everyone in the United States. Okay, so we'll say, kind of following what I said at the beginning, right? Is it a sample or population here? And I'd say population. That's kind of obvious too, because I just sort of by chance gave you guys a similar example at the beginning of the first video, right? This would be a population because I'm looking at, oops, sorry about that. Oh, okay. Because I'm looking at all individuals or everyone, all people, will say, in the US. Yeah. Survey results of all people. Okay, so what would a sample be? A sample might be what? Just a collection of, let's just say, 1 million. You can have a large sample like that, still only a sample because it's not the entire population, right? So a collection of 1 million, what do you say? US citizen survey results. Okay, how could you argue that this is a what's it called? A sample instead? And the answer is yes, you could, because you could say United States, that's a sample of the entire world, right? So you have some survey of people in the United States, but maybe your actual population was not only in the United States, is also other people everywhere. But again, that's not a very good sample, right? Because the United States is not a good representation of the world. It's a very specific place, probably different from the average place in the world. So more and more so, it's seeming to me like it really should be population only. Okay, D, the height of Avengers who can fly. Oh, this is one where it really could go either way to me. I'm gonna say, what I'm gonna do, I'm gonna look ahead actually and see, look, the height of superhumans who are Avengers. So this is looking to me like I think a sample. Actually, but again, this is one that's super ambiguous to me. Let's do it 2 ways. So correct answer could be, did I say sample last time? I said sample. I forget what I just said. We'll go with sample. And why sample? It's only some of the Avengers, right? It's only the height, the heights of some. So technically speaking, again, yeah, the data that we're looking at is not the Avengers, but it's the heights of them. And so if you think back to our definition of population and sample, a population is the data of everything, right? Sample is the data of a subgroup. Subset, I mean. Okay, so correct answer is the sample is only the heights of some of the Avengers. So the population would be the heights of all Avengers, right? Excuse me, I did not capitalize Avengers. Sacrilege. Of all the heights of all the would be the heights right? What's wrong with heights of all Avengers? Am I just terrible at grammar? I'm just gonna ignore you. Okay. So what about the alternative though? So what's the alternative answer? Alternative answer could be it's a population, and it's all the heights of Avengers who can fly, right? And then a sample could be just some of the Avengers who can fly. Right? Okay, running out of space here. What should I do? What should I do? I'm just gonna move this up a little bit. Actually, I'm just gonna delete this because you're just watching this video. You're not even getting this anyway, right? So I'm just gonna go down here, pretend that this was here the whole time. Okay, where was I? Yeah, okay. I'm gonna letter E here. Okay, so E, I'm answering the question of now the heights of superhumans who are Avengers. Okay, so what do you guys think? Well, I'm assuming that you tried this already, right? So again, kind of ambiguous case, but what I was originally getting at is the correct answer here swaps. So if you look at it, the height of superhumans who are Avengers, in the previous example, the correct answer, the population was the heights of all Avengers, whereas in this case, height of superhumans who are Avengers, the heights of all the Avengers is only a sample. So answer sample again, but in the last question, the population was the heights of all Avengers, right? In this case, the heights of all Avengers is the sample. Why? It's only the heights of some of superhumans, right? The population, what would the population be? The population would be the heights of all superhumans. Okay, I kind of changed format here, so let's go back to consistency. Population would be the heights of all superhumans, yeah? Yeah, so see, isn't that interesting? The heights of the Avengers was in one scenario, the population, but in this last scenario, now it's a sample. And you could also argue that it's actually the population again, if you're only concerned about those Avengers, and you maybe could take a subset of them. But yeah, I'd say the correct answer, because of this word here, because of this mention of superhumans, of which the Avengers are only some of them, then it makes sense to call that the sample. Okay. So what's the what's the what's the word I'm looking for? What's the conclusion to all this? That's not the actual word I'm looking for, but it means basically the same thing. So what's the takeaway from all this? The takeaway is that you could actually be right either way as long as you're paying close attention to the context. But why is there sometimes a quote unquote correct answer? The quote unquote correct answer comes because the sample, if it's a good sample, should be a representation of the population. And what makes it a good sample that represents the population is that it's randomly taken. So if I want to represent all United States data, I don't want to just grab from Hawaii, because Hawaii is very unique. I want to grab from Hawaii, from Nevada, from California, from New York. I want to grab all over the place, right? I want to grab randomly from everyone. And that gives me a better picture of the overall population. Okay, we got 2 more questions. Again, pause the video and try them out before you, oh, it's a typo here. Before you actually watch the video. Let me correct that first. Okay, so this was taken from an actual a year at KCC. So I'm not sure if this is actually last year anymore, but one of the years, KCC spent a total of $2,150,694 of student financial aid and scholarships on its 8,101 students. What is the data set? And is the data a population or sample? And finally, is this descriptive or inferential statistics, and explain why? Okay, so let's answer those questions one at a time. So first of all, determine the data set. And remember, guys, what is data again? The information from observations, counts, measurements, or responses. So it's that information from those things, right? Okay, so what is the data set though here? Is it the students? Is it the financial aid? Is it that 2,150,694? Is it the 8,101 students? So I get all kinds of answers here. But let me tell you what the correct answer is. Correct answer is it's the money. That's the data set. And I would actually add the other pieces of information too, though. So it's $2,150,694 financial aid spent on this 8,101 students, or I can just say spent on KCC students. Okay, so that is the data set. It's again, what is it? The information coming from the observation, counts, measurements, or responses. Okay, is that a population or sample? So, this is where a lot of people get tripped up. It seems like I'm talking about population sample. What isn't a population the students? Doesn't seem like the population should be the students, but actually the population is the data coming from those students, all those students, right? I gave the way to answer actually just now. It's a population. Why is it population? Because we're talking about all students. So the data is a population. Why? Because it represents information or data coming from all KCC students. And again, this is another case where context is everything, but I'm going to say here, we're looking at only one institution. It doesn't make sense for KCC's, this to be a sample because that's only one very specific spot, right? It's only KCC. So we're looking at all of KCC. KCC is not going to represent a bigger population very well. So that should be the population. It's all the students, right? All 8,101 students. And it's all the money spent on them. So this money here, that's the data for all the KCC students. That makes it a population. And finally, is that descriptive or inferential? The answer is descriptive. Descriptive. Why? It's describing. Obvious, okay? It's describing, right? You're not making any inferences. You're not drawing conclusions about the population. In fact, you have data for the entire population. Describing the data instead of making inferences. Okay, next question. Last question of the section, and we're done, and we'll take a break. A survey of 750 parents found that 87% support their kids financially until they graduate from high school, and 46 provide financial support until they finish college. Determine the data set. Okay, so the data set really is kind of everything here. It's pretty much everything that you see. It's the shorthand way to say this is it's the survey results of the 750 parents. That is the data set. Okay, so if you want to get down to the more detailed nitty-gritty, this includes the 87%, I should say the fact or the result. Yeah, I already used the word result. So the fact that 87% of them, of these 750 parents, supported through high school, and 46% supported through college. Okay, so that's the data set. Is it a population or sample? What do you guys think? Population or sample? I think it's a sample because 750 parents, that's not all the parents, right? That's only a small collection of parents. So this is a sample, since it's only some of the parents. Or that's actually wrong, because it's not some of the parents that's the data set, it's some of the results. It's only the results. Sorry, I should say it this way. Only the results from the survey results of some parents. Of some parents, right? Not all parents. That makes it a sample. Okay, let's see. Is it descriptive or inferential? That's kind of a tricky one. At this point, I'd say it is only descriptive, but with the I'll say with the potential of becoming inferential. Why am I saying it this way? Well, at this point, they didn't make any inferences, right? But it's a sample that you're looking at. So anytime you're looking at a sample and you have some kind of data, you're right at the cusp of becoming inferential, right? Because you just extrapolate that result and you just say that, oh, maybe that's true about the population, and that's an inference. That's an inference. When you draw a conclusion based on what you see in the sample, and you extrapolate that to the bigger picture, you're making an inference. That's really what we mean typically when we say inferential statistics in the field of statistics. Okay, so coming to the last question, what are some possible inferences? I get a variety of answers here, and it's a pretty open-ended question. So probably whatever you put down is correct in a way. Like I get people saying that, okay, maybe there's they come up with different reasons why their parents are supporting or not supporting their kids, or they say something like maybe I don't know, kids live at home through high school but not always through college, or they'll just come up with a variety of reasons. And these are inferences. That's valid. You're making an inference. Those are inferences. At the same time, there's also sort of a standard inference to make here. And the standard inference to make is just take what the result is for the sample and just make that same conclusion about the population. So what I mean, okay, standard inference would be maybe 87%, and I'll just add a qualifier here to be a little safer. Maybe roughly 80%, 87% of all parents support their children through high school. And because these are all inferences, I'm just going to add maybe there, because these are not certainties, but they're kind of guesses based on what we see from the data that we see of the sample, right? So here's another one, similar, right? Maybe roughly 46% of all parents support their children through college. Okay, and here's a couple other ones that are kind of along the same vein without maybe mentioning the exact numbers. So I'll say maybe the majority of parents support their children through high school. That's really just another way of saying that greater than 50% of parents support their children through high school, right? And if we look at this statistic, right, if I have this number 87% from my sample, then to say that the majority of all parents support their children, that's a pretty good inference, I'd say, right? It's pretty likely, it would seem. You could say other things like maybe more parents support their children through high school than through college. And that's not guaranteed to be true, because I'm only looking at 750 parents. So it might not be the case, but that would also be a pretty solid inference to make, right? Just looking at the numbers, 87% of this 750 group are supporting, and only 46% are supporting through college. It seems to make sense that it's a big gap between how many of all parents everywhere are going to support their children through high school too, right? So what am I doing? I'm looking only at the results from this small group of 750 parents, and I'm drawing similar conclusions about the entire population. You might not actually be correct in that, because if you have 1 million parents, this 750 parents might be unusual, right? It could be unusual. So it's not guaranteed, but if it's a random collection of 750 parents, it's very likely that these conclusions I've made, especially these bottom two, are probably true. So that's what an inference typically is. You take a sample and you make a conclusion about the population. Okay, guys, that's it for 1.1. As always, please email me if you have any questions, comments, or yeah. If you have anything you want to talk about, you can also set up a Zoom call or yeah, just don't feel free to reach out anytime. Otherwise, I'll see you guys pretty soon in the next section. Make sure you take a break before you start that one.